Hello and welcome. In this video, we're going to focus on how the characteristics of quadratics can be used and identified from intercept form of a quadratic. So in the last video, we focused on standard form and vertex form, and in this video, we're going to focus on a new form, or a form that's new to us, called intercept form. So let's go ahead and jump right in. So let's first talk about what intercept form is. When the graph of a quadratic function has at least one x-intercept, it can be written in this specific form, which we can see here, and this is called intercept form. So a times x minus p times the quantity x minus q, where a is not 0, otherwise this wouldn't be a quadratic, and p and q are actually our x-intercepts. So p and q are our x-intercepts. Because if we plug p into the function, we get 0, and because if we plug q into the function, we get 0. So what I mean by that is if we had f of x equals 2 times x minus 6 times x plus 3, in this case, p would equal 6, and q would equal negative 3, because it's the opposite, since it's happening inside, it's the opposite of what we see here. And what would happen if I took 6 and I plugged it in here? This would become 0. 2 times 0 times, it doesn't matter. 2 times 0 is 0. 0 times whatever this would be, which if I plugged in 6, this would be 9, is still going to be 0. Similarly, if I plugged negative 3 in here, this is going to be 0 times whatever this is also going to be 0. So intercept form is giving us those two x values where we're crossing the x-axis. So because f of p is 0 and f of q is 0, p and q are the x-intercepts of the graph. And we want to actually write those intercepts as ordered pairs. So we can go from the expression or the term x minus 6, we can say that there is an x-intercept at 6, 0. And we can go from x minus 3 to saying there's an x-intercept at negative 3, 0. So these would be our x-intercepts from this quadratic. The nice thing about intercept form is we can immediately pull two ordered pairs from the function, right? If I just identified I have an x-intercept at 6, 0 and negative 3, 0, I just found 2 points that I can plot, that I can graph, that I can use to help me along the way. The only thing that is sort of a bummer is that from intercept form, it's not easy to tell what our vertex is. But we know that our vertex is going to be exactly halfway between these 2 points. So I want to just draw a quick little sketch of an axis here. If I graphed 6, 0 and I graphed negative 3, 0, exactly halfway between them, which in this case, exactly halfway between them is going to be somewhere about right here. But exactly halfway between them would be the vertex. So we can actually figure out what the axis of symmetry is by adding those two numbers and dividing by 2. So in this case, 6 plus negative 3 is 3, divided by 2 is 3 over 2. So our axis of symmetry would actually be exactly halfway between them, x equals 3 over 2. And again, that's coming from using this formula. Well, if this was a nicer graph, I could actually tell exactly that value, and I may not have to use that formula. So if I wanted to find the vertex, I would plug in 3 over 2, and I would find the y value of the vertex, in the same way that we did in the last video for standard form. Similarly to both standard form and vertex form, A is still telling us whether our quadratic or our parabola is going to open up or down, and it's still telling us about our vertical stretches or shrinks. So let's take this idea of intercept form and let's apply it to graphing and see how we can graph functions that are in this form. Okay, so if we have a function that's in intercept form, the very first thing we want to do is identify what those intercepts are and plot them. So we get to start right away, potentially with 2 intercepts that we get to plot. Then we're going to find the axis of symmetry. We can either use this formula, or I'm going to show you how, if we're graphing it, oftentimes we can just identify it from the graph. And we're going to plug that in, the axis of symmetry in, to find our vertex. Then we just need 1 or 2 more points to make sure that we have a 5 points, or at least enough to fit on the graph to graph the shape of that quadratic function. So let's start and kind of walk through this step by step. The very first thing we want to do is identify our x-intercepts. So our x-intercepts are going to occur at -3, 0. That's what would make this equal 0. And at 1, 0. That's what would make this equal 0. So I'm going to start by plotting those 2 points, -3, 0 and 1, 0. The axis of symmetry is going to be exactly halfway between them. So exactly halfway between those two values, here's my axis of symmetry. And that line, what is x right there? That line is x equals -1. Now, you could also use this formula to get that. Our intercepts were -3 and 1, so I can add them together and divide by 2 and get that the axis of symmetry is x equals -1 mathematically. But if I don't have to, if I'm already graphing, I may as well use the graph to my benefit. Now, to find the vertex, I need to plug in -1 and figure out what I get. So plug x equals -1 in. When I do that, f of -1 is going to be -2 times -1 plus 3 times -1 minus 1. This is going to be -2 times 2 times -2. So this is going to be +8. So our vertex is the point -1, +8. So let's go ahead and graph that. That's going to be right here. Now, before I do anything else, I can already tell the shape of my graph is going to be upside down, and I want to make sure that's true. There's a negative in front, so it should be opening down. So I already feel a little bit better knowing that this is the shape that I'm seeing. Now, I would like you to have 5 points on your graph if it fits. So we either need to plug in this number, -2, or this number, 0, or maybe a number out here. So I'm going to pick my favorite number. My all-time favorite number to plug in when I can is x equals 0. And I want to plug this in to find one more point. So if I plug in 0, I'm going to get -2 times 3 times -1, which is going to be +6. So now I have the point 0, 6. Anything we have on one side of our dotted line, we can reflect over to the other side. So I now have 5 points, and I can sketch the shape of my quadratic. So recapping what we did, the first thing we did was we identified our x-intercepts and we graphed them. Then we found the halfway point between them, or the halfway line between them, to identify our axis of symmetry, and we plugged that in to find the y value of our vertex. Then we needed one more point that we could reflect over to the other side, so we picked any number. I chose to pick 0, plugged it in to find that output value, and then reflected that over to the other side. So oftentimes the y-intercept is going to be an easy point for you to find. You're not always going to be able to use it, but when you can, it's going to help you out. So let's go ahead and look at number 2. Let's start the same way. So let's start by identifying our x-intercepts, 6, 0, and 2, 0. And I'm going to plot those, 2, 0, 3, 4, 5, 6, 0. Now I'm going to find my axis of symmetry. So I want to find that line where if I folded it across this line, these 2 points would line up. So my axis of symmetry is going to be x equals 4, which means 4 is also the x value of the vertex. And how do I find the y value of the vertex? I plug in 4. So g of 4 is 1/4. 4 minus 6 is -2. 4 minus 2 is 2. So I'm just plugging it back in up here. And this is going to give me -1. So my vertex is the point 4, -1. And I'm going to go ahead and graph that. Now I'm noticing that the shape of this quadratic is going to open upward, so I want to confirm, yes, my a value is positive, so it should be opening upward. And now I need another point, so I'm going to choose 0 again. I love choosing 0. So if x equals 0, g of 0 is going to be 1/4 times -6 times -2, so that's going to be 12 divided by 4, which is 3. So I can graph the point 0, 3. And I can reflect that over to the other side, and then I can connect my points to make my U-shaped parabola graph. Let's look at 2 more graphing problems. All right, the very first thing I want you to do, now that we've done a couple of these together, is I want you to go ahead and find on both 3 and 4 your two x-intercepts, find your axis of symmetry and your vertex, and then stop. Don't graph anything except maybe graph your x-intercepts because that'll help you find your axis of symmetry. But before you work through everything, I just want you to work through the x-intercepts, the axis of symmetry, and the vertex. So go ahead and pause the video. All right, hopefully you had time to work through this. Our x-intercepts are -1, 0 and -5, 0. So I'm going to plot those. And then I'm going to look exactly halfway between them to figure out what my axis of symmetry is. This axis of symmetry is going to be x equals -3. And to find my vertex, I'm going to plug -3 in. So h of -3 is the opposite of -2. -3 plus 1 is -2. -3 plus 5 is +2. So this is going to be 4. So my vertex is going to be the point -3, 4. Similarly for number 4, I can start by identifying my x-intercepts 4, 0, and -2, 0, and then plotting them. Exactly halfway between those two intercepts is going to be my axis of symmetry, which is x equals 1. I can plug that in to find the y value of my vertex. So g of 1 is -1/3 times -3 times +3, which is going to be +3. So my vertex is at the point 1, 3. Couple things I want to check before I keep going. This looks like it's going to open down, and it's supposed to, so that's good. This looks like it's going to open down, and it's supposed to, so that's also good. Now on number 3, if you notice, there is no stretch or shrink happening here. So if you notice that, and you know where you can put 2 more points because this is just a reflection and translation of the parent function, go for it. But I'm going to assume that maybe some of you wouldn't see that right away. So I'm going to go ahead and plug in 0 to find that point. But if you know the parent function, you can actually just add those 2 points right there because there are no stretches and shrinks. So if what I just did confused you, then you're going to be looking at this work down here where we're plugging in 0. If I plug in 0, I get negative times 1 times 5. So the y-intercept, or our next point, is at 0, -5. And I can reflect that point over to the other side, and I can connect. Oops, that point should have been right here. I can connect to get my U-shaped graph. All right. Now, there is a stretch happening on number 4, or there is a vertical shrink of 1/3 happening. So I need to find another point. So I'm going to plug in x equals 0. When I do this, I'm actually going to end up with a fraction. I'm going to end up with +8/3. Now, if you want to, you can try and plug in a different number that will maybe not give you a fraction, might make it a little easier for you to work through, but it might take you a while to find a number that doesn't give you a fraction. 8/3 is just 1/3 less than 9/3, and 9/3 is 3. So I'm going to just go a little bit less than 3 on my graph, and I'm going to put a point, and I'm going to connect and make my quadratic. Sometimes we don't get perfect ordered pairs, and we just have to do the best that we can with what we have. Okay, so we have focused on graphing. I want to look at one problem, which actually isn't in the copy of the notes, so I'm going to make one up. I want to look at one problem where we actually analyze all of this without having a graph. All right, so here's an example that is in intercept form, but it maybe doesn't look so obvious that it's in intercept form. It might help you to rewrite it like this. That might allow you to see that it's in intercept form. So let's go ahead and identify those two intercepts, 0, 0, and -4, 0. Now, if I didn't ask you to graph, could you find the vertex? Could you find the axis of symmetry, and could you find the vertex? And I'm hoping that the answer to that question is yes. If I'm at 0 and -4, what's exactly halfway between? That's my axis of symmetry. That's going to be x equals -2. And if I have the axis of symmetry, I can plug that in to find the y value of the vertex. So if I plug in -2, I'm going to get -4 times +2, I'm going to get 8. So our vertex would be -2, +8. Now, can you tell me if that vertex is a max or a minimum? Can you tell me what that max or min value is? Can you tell me where the function is increasing or decreasing? Can you do all of those things without having to graph? Because I really don't think you want to graph. So let's just briefly talk about this. If the number in front is positive, that means that our quadratic is going to open upward. And if our quadratic is opening upward, then we can identify that this quadratic has a minimum, and that minimum occurs at the y value of the vertex, which is 8. Next, we can see that it is decreasing to the left of the vertex, so it's decreasing from -infinity until we get to the vertex, which is -2, and it's increasing from -2 as we go on forever to infinity. So I just wanted to stop and take a quick look at how we could analyze this function even without graphing it. So now let's look at a real-life problem and see how it benefits us to have this equation in intercept form. So we are going to be looking at some golf shots here. So here we have a golfer, ball starts on the ground, gets hit out, and lands on the ground again. So it's forming this parabolic arc. We can see it starts at 0, 0, which makes sense. We are starting at 0 distance, at 0 height. We're hitting the ball, and it's going up to a maximum height of 25 yards at a horizontal distance of 50 yards, then it's coming back down and it's hitting the ground. So if we look at this shot, and it says in the words over here, the parabola shows the path of your first golf shot where x is the horizontal distance in yards and y is the corresponding height in yards. So this graph over here off to the right, this is our first shot. The next sentence says the path of your second shot, can be modeled by this function here. So I'm going to go ahead and use purple for this function. This is not our first shot. This is our second shot. I just said it's not our first shot. Second shot. So this function does not go with this graph. This graph does not go with this function. First shot, second shot. Part A says which shot travels farther before hitting the ground. So let's look at each shot individually. The first shot, we can actually look at the graph and see how far does it travel before it hits the ground. How far? Well, it starts at 0 and it hits the ground at 100 yards. So it travels 100 yards before it hits the ground. The second shot is not so obvious. We could graph it. I'm going to wager that none of you want to do that. We could graph it, or we could just identify what these two x-intercepts are for our function and figure out how far away from each other they are, because that would be the total distance. So what that means is I need to identify the two x-intercepts. So the first one, which I can find from this piece right here, is 0, 0. The second one I can find from this piece right here is 80, 0. So how far is it from one x-intercept to the next? It is 80 yards. So which shot traveled farther? The first shot traveled farther before hitting the ground. Part B says which traveled higher. So now we're not talking about the x-intercepts anymore. We're talking about the maximum height. The maximum height is going to relate to the y value of the vertex. So again, from our graph, we can see what the highest this graph ever goes, the y value of that vertex. The highest that our first shot ever goes is 25 yards. The one thing that we don't love about intercept form is that we can't identify what our vertex is right away. So in order to find the vertex, we need to first find the axis of symmetry. The axis of symmetry is exactly halfway between our two x-intercepts. So exactly halfway between 0 and 80 is going to be 40 yards. Then we just need to plug in 40 to figure out what that y value of the vertex is. So I'm going to rewrite this -0.02. That's the same thing as 2 over 100, or -2 over 100, which is the same thing as -1 over 50. This is going to become 40 times -40, which is going to be -1600 and I can divide those both by 10. So now I really just need to figure out what is 160 divided by 5, and that's going to be 32. So our second shot has a maximum height of 32 yards. So which travels higher? The second shot travels higher. So again, horizontal distance, we're talking about the x-intercepts. Height, maximum height, we're talking about the y value of the vertex. Now this last question relates to what we've already been talking about. It says use the graph from problem number 1, and now we have a third shot, g of x, for us to compare to and make some decisions and ask some similar questions. So the question being asked here is, does your first or third shot travel farther before hitting the ground? Well, we already talked about how our first shot travels 100 yards before it's hitting the ground. That's from part A. Actually, I should say from 5A. Now, we need to figure out how far is talking about our horizontal distance. So we need to figure out how far apart our x-intercepts are. So let's go ahead and identify our x-intercepts. This one is at 0, 0. This one is at 40, 0. So how far apart are they? They are 40 units apart. Or in this case, 40 yards apart. So which shot travels farther? The first shot travels farther before hitting the ground. So the key thing I really want you to think through when you're reading through quadratic word problems is, what is it asking me for? Is it asking me for some sort of horizontal distance or horizontal time? Because then I'm going to be looking at the distance between those x-intercepts. Is it asking me about the time or the distance when it reaches its maximum height? Because that's going to be asking me about the x value of the vertex. Is it asking me about the maximum height? That's going to be asking me about the y value of the vertex. So really think through what a question's asking you about before you just get intimidated by the fact that there are lots of words in our word problems. All right, let's wrap up what we covered in this video. We talked about intercept form and how from intercept form we can take our two x-intercepts. In order to find the vertex, we can figure out what x value is exactly halfway between those two intercepts, and then plug that in to find the y value of the vertex. Then we can use the same strategies we've been using to graph. Plot our axis of symmetry, plot our vertex. Now we have our x-intercepts to plot. And we can find one more point to graph and reflect to the other side. And then lastly, we wrapped up on how might this apply in a real-life problem, and we analyzed some word problems. So go ahead and write any questions down that you have, and I look forward to supporting you on this. Thanks for listening.